So let's suppose that the algebra gods have smiled upon us and asked us to graph a line given its slope, so we already know that its slope is 3 in this example, and also given some random point, 2, -1, along this line. How do we use that information to produce a graph? And this is what I called before the stair-step technique. So here's the strategy. Given this information, we're going to start by using the point that we're given as a place to begin. Right? So 2, -1. We know that that point's on our line, so we're going to use that point right off the bat. We're just going to draw it right in there. And then from that point, we're going to use our slope to stair-step our way to find another. And as soon as I find 2 points, all I have to do is draw the line through those 2 points and I'm done. So first, we'll take that known point, 2, -1, and plot it. Just throw it right there on the graph paper to get yourself started. Then we're going to take the slope that we know. In this example, that slope is 3. And use that slope to determine a rise and a run. After all, that's what a slope is. It's a quotient. It's a result of a division problem between rise, a vertical difference, and run, a horizontal difference on a graph. And once we have identified a rise and a run that our slope is telling us about, we're going to, starting from our starting point again, move vertically by the amount which we call the rise, and horizontally by the amount which we call the run. After we've done that, we will end up at a second point on this line, from which all we have to do is connect the dots. All right, first things first. We know that this line has the point 2, -1 on it. So let's plot that point before we do anything else. 2, -1. There it is. That was easy. All right, second step. Let's look at the slope. We know that the slope of this line is 3. But on the other hand, we know that a slope is a rise divided by a run. And so usually when we think of slope, we think of it as a fraction. We think of it as a result of a division problem, a quotient. But here we have a whole number written as our slope. So before we can interpret it in that way, we need to turn that whole number into a fraction. And the way to turn any whole number into a fraction, easiest way anyway, is just to give it a denominator equal to 1. So whenever you have a whole number, you can remember, let's think about 1 as being the denominator. Now, both numerator and denominator of this fraction happen to be positive, which is going to be really important in just a second. So now that we can see the slope as a fraction, we can see its numerator as a rise and its denominator as a run. So what does it mean that we have a rise of +3? Well, because rise is the vertical measurement on my graph, and I have a positive amount of rise, that means that we're increasing the value of y as we go from one point to another. So that means we're moving up. So +3 for a rise means we're going to go up 3 units. Likewise in the denominator, here our denominator is a run of +1. And because run is a horizontal coordinate, it's an x measurement, that means we're going to increase the value of x by 1. And when we increase values of x, we move from the left to the right. So having a slope of 3 means that we can locate 2 different points along this line by starting at one point and then going up 3 and to the right 1. Let's do that. I'll go up 3 from the point that we know, 2, -1, and then to the right 1 from there, and label another point, which happens in this example to have the coordinates 3, 2. Because once we've risen up by 3 units, we've gone from a -1 as our y-coordinate up to a 2 as our y-coordinate. And when we run to the right by 1, we move from 2 as an x-coordinate to 3 as an x-coordinate. Great, so we've located a second point along this line. And Euclidean geometry being what it is, we know all we have left to do to graph our line is to connect the dots. So if we know a point and we know the slope of a line, then graphing it is a simple process of just starting out using that point. So sort of plant your feet at the point that you know. Then analyze your slope, take it apart, identify that slope as a ratio between a rise and a run. In this example, our slope was a whole number, so we had to think of the denominator of that fraction as being a 1, most convenient way to do it. And then as soon as we know that we want to rise by a certain amount and run by a certain amount according to our slope, then that's all we have to do, starting from the point that we planted our feet at. Here we rose up by 3, we ran to the right by 1, and located a second point on our line. And the instant you've located a second point on your line, you can connect the dots and have a graph for the line itself.